Alright, so in this section we're going to be talking about exponents, and I'm going to be explaining the different rules regarding exponents. And then in the following video we're going to be going over the examples of the exponents. And since there's only 5 of them, I'm probably just going to be going over all the examples. But I would just like to point out that at this point we should all be familiar with the order of operations as well as fractions, since those have been discussed in previous videos. So if you're still not completely comfortable with those, please revisit those previous videos, and if you have any questions, please come into the tutoring center. So getting started, like I said, we're going to go over the explanation of exponents, what they are, and different rules that apply to the exponents that allow us to manipulate different problems. And these rules that I'm going to talk about are on page 5 of the study guide, and actually on the bottom half of page 5. So if you're following along, please go to page 5. And the first rule I want to talk about, well, let's just talk about the basics of, not on this page, but just the basics of what an exponent is. And an exponent basically says that if I have, say, 5 squared, I want to multiply whatever's in here by itself this many times. So this would be 5 times 5, and as we're sure many of you are familiar, that is just 5 squared is just 25. But if I have something like this, say x plus 1 squared, and depending on what math classes you may or may not go into, you may not see this, but it doesn't matter. Whatever's in here, I'm going to multiply by itself that many times. So I'm going to say x plus 1 times, and since there's a 2 up here, I'm just going to do it twice, x plus 1. So you can't just distribute this 2 to the x and say it's x squared and then distribute this here, and 1 squared is 1. So it's not x squared plus 1. If we FOIL this out, it would actually be x squared plus 2x plus 1, which is much different than just x squared plus 1. So it's important to realize that all we're doing is multiplying whatever's within the parentheses by itself, whatever number the exponent is. And if there's a negative, we have a 5 up here, but if it's negative 5 in the exponent, so if it's something like this, negative 5 squared, then we would simply put that negative 5 down. So negative 5 times, and again, we have to multiply it by itself, so times negative 5, and that's equal to a positive 25. So that's all an exponent is. It's just multiplying whatever's within the parentheses by itself this many times. However, if it was a 3, then we multiply it by another negative 5. Okay, so now that we've discussed that, let's talk about some of the other, a little bit more advanced rules regarding exponents. The one I want to talk about first says that, let me scroll down a little bit here, says that if I have a times b and I raise it to the m power, I can rewrite that as a to the m power times b to the m power. I'm basically distributing that exponent to each of those. Now why that is because, as I'm sure many of you know, and if you don't, that's okay, but if I have just say 5 here, I can rewrite that as just 5 to the 1. Any number, anything raised to the 1 power is just itself, and we don't write it down. You don't see 5 to the 1 written down because it's superfluous. It's just redundant information. And just a quick side note, if anything, this is another, I don't know what that was, anything to the 0 power is just 1. And that's another rule that's on that page that I'm not going to cover too closely. Just realize that anything to the 0 power is 1. But anything to the 1 power is just itself. So really, inside these parentheses over here, that's really just a to the 1 and b to the 1, since I didn't put any other numbers there. I didn't put a 2 there. And what I'm doing, and this is another rule that I'll talk about in just a minute, but I'm really distributing that m to each one of these, right? Well, m times 1 is just m, which is why I just have an m here. But if I have, say, something like a squared times b cubed, and I raise that to say the 2 power, I'm going to distribute that too. And what I'm going to do is I'm going to multiply, and I'll go in depth on this rule a little bit in just a second. But let's see what happens here. I want to distribute this 2 to each one of these, and I'm going to multiply. So this becomes a to the 2 times 2 is 4 times b, and the 3 times 2 is 6. A to the 6th, a to the 4th, b to the 6th is what it would be simplified to. So what that rule is that I just did there is that if I have something like, let's say, a to the 3rd power, and I raise it to say the 4th power, I'm going to multiply those two numbers. So, and again, this is another rule on page 5. So this would be a to the 3 times 4 is 12. And why that works is, well, we just discussed what an exponent is. So what this really means right here is that this is a to the third times a to the third times a to the third times a to the third. We have 4 of those because we're raising it to the 4th power. And if we multiply this all out, then we have, what is a to the third? Well, a to the third is just a times a times a. And we have that 4 times, so essentially we have 12 a's going along the bottom here. And if we have 12 a's multiplied by each other, then that's just going to be a to the 12th. And that brings up another rule. So just a quick recap of this rule. I'm multiplying these two numbers. If I have a to some exponent and I raise it to another exponent, I'm multiplying those two numbers. So right here we can see that I have a to the third times a to the third times a to the third times a to the third. Well, there's another rule that says that if I have a to the, let's say, third, and I multiply it by, say, a to the, I don't know, squared, a to the 2nd power, if I'm multiplying two things with the same base, so a times a, with different exponents, if I'm multiplying them, I add them together, so a to the 5th power. And again, as I break this down, this is a times a times a, and I'm multiplying it, so times, and a squared is a times a. So now I have 5 a's all times each other, and that's just a to the 5th. So if you're multiplying two things with the same base, with different exponents, or even the same exponents, you're adding those exponents together. A very simple example of this is if I have x times x, well, again, this is x to the 1 and this is x to the 1. I'm adding those exponents together, so this is x squared. All right, so that's another rule that we just went over. Another rule, I just said that if we multiply the same base, then we add their exponents together. Well, what happens if I divide? What happens if I have, say, a to the 5th divided by a cubed? What would you think happens? Well, intuitively, we would think, well, if we're multiplying, we add them together. So if we divide, do we subtract them? And that's actually right. We subtract them. So I would have a to the 5 minus 3, and that's a squared, or a to the 2nd power. Well, why does that work? Because now I have 5 a's, so a times a times a times, times a times a, and I'm dividing that by 3 a's, so a times a times a. And since I'm multiplying all these together, I can start canceling like terms out. Well, all the terms are alike, so I'm going to cancel this a out with this a. I'm going to cancel this a out with this a, and I'm going to cancel this a out with this a. And essentially, all these terms are just ones. And what I have left is a times a, which is just a squared. All right, well, going along these same rules, but making it a little more complicated, what if I have, say, a to the 3rd power, and I multiply that, and I have, say, a to the negative 2 power? Well, what do I do there? Well, we just add them just like we did before. So we have a to the 3, and I'm adding plus, well, I'm plussing this whole thing there, so that's plus a negative 2. Well, 3 plus a negative 2 is the same thing as 3 minus 2, so that's a to the 1 power, or just a. Like we said, anything to the 1 power is just whatever it is. All right, so that's not too complicated. Well, what if I have this? What if I have a to, let's say, the 3rd power again, and I divide it by, say, a to the 5th power? What do I do there? Well, again, we're just going to subtract them. So now I have a to the 3rd power minus 5, right? I'm dividing, so I'm subtracting. So now I have a to the 3 minus 5, and that's a to the negative 2. And this is where it might look a little confusing. And in the book, there's a simple rule that just says if you have a negative exponent, you can put it 1 and put that on the bottom, so a on the bottom, and then you change the sign on the exponent. So that becomes 1 over a squared, a to the positive 2. We change the sign because we put it on the denominator. Now, why does that work? Well, let's write this out like we did with the other ones. I have a times a times a, and I'm dividing that by a times a times a times a times a. I have 5 a's on the denominator now. And I'm going to cancel these out like I did before. That a with that a, this a with this a, this a with this a. These all become 1s. And so what I'm left with is a squared on the bottom. I have a 1 on top, and I have an a squared on the bottom. So you can see it's the same answer that we got. 1 over a squared. All right, so to take this a little bit further with an example that you probably won't see. I'm going to scoot it down just a little bit. With an example that you probably won't see, but just to clarify what we can really do with this is, if I have, say, 5x squared over, let's say, 3, then I can change this. I can just rewrite this. This is just different notation. I could say, well, this is 5. The coefficient stays up there. Over 3, this coefficient stays in the denominator. And I'm going to move my variable and make it a -2. I don't know why you would want to do that, but we could. I could move the variable down and change the sign on its exponent. If I have something like, let's say, 3 over, I don't know, we could just go backwards. If I have 3 over, let's say, 7 x to the, I don't know, -3, then again, it doesn't necessarily have to go, well, if it goes to the numerator, it's a positive. If it goes to the denominator, it's a negative. You just change the sign wherever you move it. So if I move this, this is going to be 3x cubed, positive cubed, because I'm changing the sign right here, over 7. I'm just moving the variable. The coefficients stay where they are. So hopefully that's not too confusing. And again, if you have any more questions, post them below or come into the tutoring center with any clarification. But that's an important rule that you're going to see a little later on in the examples. And it's useful. It's very useful later. If depending on what math class you take, you may or may not see it. But for this test, you're going to definitely need to know what the rule is and how to use it. So there's just one more rule I want to talk about. And it's really, you don't really have to use it, but it does come in handy sometimes. If I have something like, let's say, 2 over 3, and I raise that to, say, squared, let's say the second power, then I can rewrite this as 2 squared over 3 squared. And that's very helpful sometimes. Now, if you're just doing 2 over 3 squared, you could simply, because we know about fractions, we can simply say, well, that's 2/3 times itself 2 times, so times 2/3. And we could say, well, 2 times 2 is 4, and 3 times 3 is 9, so we get 4 ninths. But if we look at the breakdown of what we just did above, we could say, well, 2 squared is 4, and 3 squared is 9, so we get the same answer. And this rule actually becomes very important as you start dealing with like variables and stuff in later classes and later equations, and it's very helpful to use. But if you're just dealing with fractions, you don't necessarily have to use that, but it actually is helpful to see that. All right, so that's the complete explanation of exponents as far as we're going to use them. And now in the next video, we're going to go over the example problems, and I will probably be doing all 5 of those. All right. All right, so in the previous video, we went over the explanation of exponents and the different rules about exponents. And those rules are on page 5 of the study guide if you want to have those with you as we work our way through the example problems. So in this video, since we went over the explanation already, I'm just going to go over the example problems. And since there are only 5 example problems in this study guide, I'm just going to go over all 5 of those. We're going to work through those together. All right, so without any further ado, let's just start with the first problem. The first problem, says, in parentheses, 3 squared multiplied by 2 cubed. And then we're going to multiply all that. I'm going to end parentheses, multiply that by 3 to the -3. And then I'm going to add, in parentheses, 3 divided by 3 to the +3. And then based on the order of operations, I'm going to work on my parentheses first. And in this parentheses, I'm going to have, well, 3 squared is just 9 multiplied by 2 cubed, which is 2 times 2 times 2, so that's 8. And then I'm going to multiply that by, well, as we discussed in our explanation, this is really 1 over 3 cubed because it's a negative exponent. We move the 3 cubed to the bottom and we can make it a positive exponent. And then we're going to add that to 3, well, let me erase that. I'm just going to rewrite that as 3, what's going on here? 3 divided by, I'm going to put my line there instead of divided by symbol, and then I'm going to put 3 cubed. All right, and the reason I didn't multiply 9 times 8 yet is because I want to cancel those out. We'll see what's going to go on, but you can multiply 9 times 8, and we can go forward like that, and we could reduce at the end. But if we reduce along the way, it becomes much, much easier on us. So I can rewrite this as 9 times 8 over, and that's just multiplying that by 1, and then if this is over 1, I'm going to multiply this denominator here by that 1, and I can just say that this is all over the 3 cubed, and 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, so over 27. And then I'm going to add that to 3 over, and then 3 cubed again, that's 27. And so there's a couple ways we can do this. We can multiply 9 times 8, and we get, and I'll do this over here, and now 9 times 8 is 72, and then it's over 27. We already have a common denominator, so I'm going to say 72 plus 3 over 27, which is equal to 75 over 27. And if I reduce and I pull out a 3, then I get 25 over 9. Now what I'm suggesting is that we reduce beforehand. And it makes it so that we don't have a common denominator, but it's easy to find that common denominator. And in this sense, it actually might be easier to find to do it just how we did it. But the other way to do that is to say, well, this 27 over here is the same thing as 9 times 3. And now that I have 9 times 3, I can cancel this 9 and this 9 out. And so I'm left with 8 over 3. And then I could say that this 27 is also 9 times 3. And instead of canceling the 9's out, I have this 3, which becomes a 1. And that 9 over there became a 1. And then I could cancel this 3 out. And so this is just plus 1 over 9. And so there's an extra step here, which now I got to find a new common denominator and do a little bit more math. But it might be easier if you can't simply, if you're having trouble reducing the 25, I'm sorry, the 75 over 27 over here, if you're having trouble reducing that to the 25 over 9, then this way might be easier because we're doing our reducing in the middle where it's easier. And so our common denominator is actually, it's easy to see that it's just 9, so we're going to multiply this side by 3. And if we multiply the bottom by 3, we got to multiply the top by 3. And so then what I get is 24, 8 times 3 is 24, over 9, plus 1 over 9, which is equal to 25 over 9. And these are both the same answers. So whatever way you got it, the beautiful thing about math is that many times there's multiple ways to approach the same problem. But either way you get it, you should get 25 over 9. All right, let's move on. Number 2. All right, number 2 says we have 2 to the 5th power over negative 2 squared, and that's plus 2 over 2 cubed. All right, so just like our previous problem, some of you may see different ways to go about solving this problem. That's perfectly all right if we get the same answer at the end. But the first thing I'm going to do is I'm going to work on my exponents. And if you can see, well, if there's different ways to do this, like I said, and depending on which way you do it, you can work on the exponents differently. But the way I'm going to do is I'm just going to work my exponents completely out. So on the top here, I have 2 to the 5th power, and if you multiply 2 times 2 5 times, then you get 32 over, well, it's important to realize that there's no parentheses around it, so this 2 squared is just 4, 2 times 2 is 4, and then the negative is not included in the squaring, so it's negative 4. And that's an important distinction to make, and that's in the rules, excuse me, on page 4, I believe, on the top half of page 4, which you should glance at. But if I wanted to include the negative with the squaring, I would explicitly write it like this over here. Let me just, I would say negative 2 squared. And then, but if I write it like this, if I write 2 squared, the negative is not part of the squaring. So I say, well, 2 squared is just 4, and then I add that negative to it, or I multiply it by a negative 1. All right, so our denominator there is negative 4, plus, well, 2 is just 2. We didn't do anything there. And then 2 cubed, 2 times 2 times 2 is 8. But now what I'm going to do here is I'm going to say, well, this is the same thing as 4 times 2. So I can cancel these out, and they're just a 1 up here. So now what my problem looks like is 32 over negative 4 plus 1 over 4. Now, it's important to realize that negative 4 and 4 are not the same denominator. They have a different side. So there's two different things you can do. You can just realize, well, I can just multiply this by a negative 1 to get to a positive 4, and then I multiply the top by a negative 1, and I get negative 32 over a positive 4 plus 1 over a positive 4. Or you can realize that if I have, say, something like negative 2 over 3, and I'm just making this up, that's the exact same thing as 2 over negative 3. I just moved the negative to the bottom. And that's the exact same thing as negative out front 2 over 3. And any kind of answer is usually written like this, but I can move the negative around. And so you could just say, well, okay, I'm just going to move the negative from the bottom to the top, which is exactly what we did by multiplying by negative 1. But in either case, you should end up with this as one of the steps in your problem. And then we just say, well, a negative 32 plus 1 is equal to a negative 31 over 4. Or I can write it like this, negative 31 over 4. But in either case, this is the final answer. The other way to do it is to pull the negative out in front and say that this is negative, and then say 2 to the 5th over 2 squared. And when we have 2 to the 5th over 2 squared, in the rules section that I explained in the last video, we can say that, well, I can just subtract those two exponents and say that this is negative 2, 5 minus 3, 5 minus 2 is 3, so 2 cubed. And then plus, well, there's a 2 to the 1, anything to the 1 is just 2, right? Over 2 to the 3. And I can say, well, 1 minus 3 is negative 2. So this would look like negative 2 cubed plus 2 to the negative 2. And I would say, well, that's the same thing as negative 2 cubed plus 1 over 2 squared. And then you'd have to find a common denominator from there. Negative 2 cubed is negative 8. Find a common denominator, and if you do it that way, you should still end up with negative 31 over 4. All right, moving on to number 3. I just wanted to show you that there are multiple ways to do one problem, and that way is actually a little bit longer, but if you get comfortable with exponents, it's actually a little bit easier. Number 3. Number 3 says we have in parentheses 2 cubed, and then that's to the negative 2 power, and then in parentheses again we have 2 squared, and I'm going to multiply that by 1 cubed, and then I'm raising that to the 2 power squared. Alright, so order of operations, we're going to work on our parentheses first. So inside my first set of parentheses I have, well, 2 cubed is just 8, and that's to the negative 2, and I'm going to multiply that by 2 squared is 4, and then 1 to any power is still 1, and that's squared. And then since I know based on the explanation that when I have a negative here, I'm going to put it have a 1 over and then make that positive. So I'm going to make that 1 over 8 squared, and then I'm multiplying that by 4 times 1 is just 4, and then 4 squared is 16. So, and then I put that over 1, and I get 16 over, and I'm going to write it like this. I'm going to write it as, instead of 8 times 8 is 64, I'm just going to write 8 times 8. Because if I write it as 8 times 8, I can say, well, that's 16 is 8 times 2. And again, you don't have to do this. You can multiply it out and then reduce later. But if I have 8 times 2, I can say, well, there's 8 and there's 8, so I can cancel it out. Now this is just 2 over 8. And I can reduce that and say, well, that's the same thing as 1 over 4. And if you want to go a step further, earlier over here, we can say that this is 4 times 2, and now we can cancel the 2's out, and this is just 1. These are all 1's. And then we don't have to do any reducing later. We just have simply 1 over 4, and that's what our answer is over here, 1 over 4. Again, there are multiple ways to do things, and as long as we all get the same answer, that's what's important. All right, so moving on to number 4. These may look like we're going through them kind of fast or they may look a little easy, and really they're not too difficult as long as we know the rules and how to manipulate exponents. And that's what this section is teaching us. So while they might look scary at first, they're really, once you know the rules, they're really not that bad. All right, so number 4. Number 4 says 17 minus 3 squared plus 7, and all of that is over 4 squared minus 3 squared. All right, so let's work this out. I'm going to work on my top and bottom, and so the top I'm just going to leave, well, 17 is just 17 minus 9. Again, since the negative is not included in a parentheses, it's just 3 squared is 9, and we're subtracting that, so minus 9 plus 7 over, well, 4 squared is 16 minus, again, minus 9 because it's not included in the parentheses. And then as we combine, we say, well, 17 minus 9 we have right here is just 8 plus 7 is 15 over 16 minus 9 is 7, and our answer is 15/7. We can't reduce that. And that's all for that one. It's just important to notice on that one that with the negative not being included in the parentheses, that we just keep it as a negative 9 or minus 9 in those different cases. All right, so number 5, as we move on to our last problem. Number 5 says 2 times negative 5 plus 3 over negative 2 squared minus, oh, this is going to look interesting, 3 in parentheses, negative 3 squared plus 2, and that's all over 3 minus, and then in parentheses, negative 1/2. All right, and so we're just going to work on these one at a time, the top, the bottom, the top, the bottom, and we'll look at what our different answers for each part are. And so inside our first set of parentheses on the top of our first fraction, we have negative 5 plus 3, and that's just a negative 2. So I'm just going to write this right here as negative 2. And we're multiplying that by 2, and so that's negative 4 over, and again, the negative on their denominator is not included in the exponent. There's not parentheses, so this is just negative 4. And then we're subtracting, and so as we move over here, we have negative 3 squared, but the negative is not included, just like we just said before. And so it's a negative 9 plus 2, and that's just simply negative 7, right? And then we're multiplying that by 3, and so we have negative 21 over, and here we have a 3, and then if we have a minus minus, that's going to turn into a plus. So we have 3 plus 1/2. All right, so let's simplify this a little bit. And so our negative 4 over 4, or excuse me, negative 4 over negative 4 turns into just 1. And then we have minus, and then we have a negative 21 still over. And then as we add 3 plus 1/2, we don't want it as 3.5. We don't want a mixed fraction, or in a mixed fraction. And so instead we're going to have, well, 3 over 1. We change this. We say, well, that's times 2 to get a common denominator. And it's actually going to be 7 over 2. So now we have 7 over 2. All right, so I'm gonna rewrite this. I'm gonna say, well, this is 1 minus, and I'm gonna put the negative out in front. This negative right here is gonna go out in front. 21 over 7 over 2. And I did that so we can see that, well, the negative, if I minus if I minus a negative number, it's just plus. So negative minus minus just turns into a plus. And then, as we discussed in the fraction videos, this would turn into, this portion here would turn into 21 over 1 multiplied by 2 over 7. We flip the bottom one. Well, this 21 can be turned into a 7 times 3 so that we can cancel these 7s out. And then we just have, again, this becomes 1. 3 times 2 is 6 over 1, or just 6. But that's just for this section over here. So now we just have 1 plus 6. Well, that's easy enough. That's just 7. And 7 might seem really like a simple answer for what we had given our problem, but really what that problem was doing, it was just throwing a lot of different things at us. It was throwing negative numbers at us. It was throwing squares and fractions, and we had to like combine them all together. But it really wasn't too tough a problem as if you have all have watched the previous videos and you understood the order of operations, fractions, and then the explanation on exponents. It really wasn't difficult. None of these problems were too difficult. So hopefully you guys understood all that. If you have any more questions on the exponents section, please come into the tutoring center and ask them. More than happy to help.